THDC serve transmission lines, hydropower plants. Membership, IEEE, INAE, and young associate. Lectures delivered 10 in different engineering colleges. Conferences and courses organized 5. Book chapter Springer 1. Publications International Journal 17. International Conference 25. I request Dr. Premalatha Madam to handle the session. Please, ma'am, on the topic monitoring and protection of microgrid system with presence of inverter-based distributed generation. I welcome all the participants for today's morning session. Kindly, please, ma'am, kindly take the session, ma'am.
Okay, thank you so much, ma'am, for your kind words. I'm very thankful to you, and in fact, this introduction is not required. We all are in the same platform, and so still, thank you so much for motivating me, and I'm very grateful to you people that for inviting me for this session, and I'm very grateful to you for saying some few words regarding my CV. But we all are in the same platform. This is not required at all. But still, so let us say I just welcome to all of you to this morning session of your program, and so I'll focus. Let me share my PPTs, and I'll just tell you what I'll today share with all of you. And of course, due to some time constraint, I may not be, but still, of course, I promise definitely we'll discuss some useful thought process through this session. So, am I audible to all of you? Am I audible?
Yes, ma'am.
Yeah,
yes, ma'am.
Thank you so much. Thank you so much. So, very good morning to all of you, and irrespective of this pandemic situation, still we all are gathered here. So that's a great, motivation for all of us. Even then, there is great pandemic situation and very COVID situation, but still with lot of effort. Yeah, my request kindly all of you mute your mic so that we'll have a wonderful session. I request to all of you kindly just.
Dear participants, please mute your mic. Shweta, please mute your mic, ma'am. Thank you, ma'am.
So kindly mute your mic so that we can easily go ahead and we can discuss in a wonderful manner. So due to time constraint, I'll just focus on smart grid protection. If any time we'll come across again, I'll go for monitoring because I came to know that I have to deliver for 1.5 hours and then half an hour for questionnaires. So before going to protection, of this particular area, so which is a very vast area, smart grid, it's a new upcoming field, and why it is required, some glimpse I'll just give you. First, I'll discuss about what is, very briefly, what is smart grid, why smart grid is required, and what is then microgrid, and then why this protection is challenging for microgrid. Okay, so these 3 steps I'll follow in my presentation. So if you could see my initial PPT, it is very clumsy and very eye-catching also, but at the same time, it is very clumsy and cumbersome. But at the same time, I promise you, this is a very, required field. At the same time, it is also a very easy field to understand. If you have motivation and if you have desire, if you have some dedication to pursue, maybe research or some kind of industry-oriented work or some teaching, whatever it may be. Because this is today's real requirement. So therefore, this topic is very important for all of us. And in fact, when I joined this IIT Roorkee as a faculty in the year 2012, so earlier my research topic was on conventional grid, like, transmission level and other parts. But when I came to know that this field is very emerging and this is required for the society, not for individual, it is for the societies, because renewables are very important. And so therefore I changed my area of thrust area. So then slowly I started my thought process in this direction. And this is a journey basically. This is, I mean, sometimes some people they ask, what do you mean by this microgrid? What do you mean by this smart grid? It is basically a journey. It's a vision. There is no such kind of product or some kind of packaging which will hand over to you and we will use it in our facilities to facilitate our system. No. So it is basically a vision. It's a kind of our motivation and vision how to deal, how to move ahead in this field. So before that, if you all of you could, we should aware about what is our Indian energy scenario. So today's date by 2020. So this is the figure. So this is a quite, I mean, good figure for all of us. 370.10 gigawatt of energy installed capacity of India. Unfortunately, I can say some part here, and fortunately, some parts are in this pie chart. So the first figure you could see that brown one is 55.4% for coal, which is not a good symbol for all of us. And all of you will be agreed that what kind of pollution level we are facing for, right? And next, the green one is a quite fortunate part for all of us, and we should be happy for that. And we could have this large hydro and renewables together, we are happy that we have 87.02 gigawatt of energy till date. India has the installed capacity. So we are in a very sound position that it's not a, I mean, if you recall before 10 years, we are completely, we don't have any facility as far as the renewables are concerned. But now fortunately, and I mean, we are with our dedication and our hard work, India is standing in front as the renewables are concerned. And that is actually the required today's date to overcome such coal-based basically to beat the coal-based generations, right? So and in this regard, if you could see that India has the major contribution from wind and solar. Wind has 45.2% contribution as far as renewable energy is concerned, that is 36.36 gigawatt, and solar has 29.54 gigawatt, that is 36.7%. And so on, so biomass, small hydro, and in fact, in MNRE, that is the new Ministry of New Renewable Energy System. So there is a scheme for installation of there is a mission for small hydropower plants. And mostly in the northern grid of India, we have the plenty of availability of water resources. So why not to harness or exploit those small plants and install small plants over there. And of course, large hydropower plants are available in also northern side and other states also. So basically, we are trying to utilize the natural resources which are actually not existing in nature, like water, like solar and wind. So which are our major resources. And from there, we will try to access more and more energy for our requirement. And in fact, why we're so much worried? Why this energy crisis is coming to our mind? Because if you see the world scenario, I'm not talking about India. Of course, India is a basically developing country, and if you see Canada, US, so those are basically the developed countries, and Europe. But however, the Asia continent is concerned. So this yellow line which shows a lot many research are there, but due to time constraint, I'm just putting a single picture in front of you. That the power demand slowly it is going, it increasing exponentially. It is not a simple curve. It is not increasing other manner. It is increasing exponentially. So anyway, this COVID situation, there is some deficient requirement of power is less, but still you can't say that this is the stalling point of our society. Our society has to grow. It has to move. So in every front, like. So we have many belts, we have industrial, starting from the customer, how many different types of customers. We have 5 types of customers. Like we have residential customers, we have industrial customers, we have commercial customers, we have agricultural customers. We have now the major the load transportation is the major customers which are going to land over in everywhere. Because the maximum and second pollution to the carbon dioxide emission, the second pollution layer comes from the transportation sector, because there we use huge amount of petrol, diesel, creates the pollution, right? So the second layer of pollution which comes from to carbon dioxide emission and it comes to the society environment, that is the transportation sector. So therefore, the government has sanctioned like more than 11,000 crores of money to quickly to have some charging stations and automobiles, electric vehicles should be launched to in India as quick as possible. So there are five those sectors. Initially, we ignored the transportation loads and sectors. Now we have to be careful for that. So in every aspect, if you see that for the modernization process, for aiming for a very bright future, developed country for India, so the energy is one of the major requirement. So it increases exponentially, and that is only possible, only possible from the renewables. And the renewables are very intermediate in nature to handle those. The smart grid concept is very essential. So these are some of the thought process why we are motivated for such environment, and of course there is some merit, so there is some demerits. So as if all of you know that reduction in carbon dioxide emission is one reason, and reduction of global warming and the peak energy deficit with renewable sources. Suppose we have some peak deficit. I mean we have. I mean there is a peak demand, but however our grid energy, conventional energy, is not sufficient to fulfill that energy. Then we have to take the help from the renewables, and maybe of course some of the storage batteries. Now the major research areas now in DST and Europe, America, Canada, India, so everywhere the major research areas now the storage system. Okay, the storage, if you have some storage, good storage facility, and from there also we can tap some energy to mitigate the peak efficient energy in the system, so that our system will not collapse and it will just run smoothly. And of course, another motivation behind is that for this movement is India is plenty available of renewable sources. We have plenty available solar energy, wind energy. It's a very good climate. This climate is very nice for generation of these two energy sources. So why not utilize those energy sources to replace the fossil fuel based generations, right? So this figure is not. This 100 gigawatt from solar, 75 gigawatt from wind, this India government is targeting by 2020. This figure is not, that much of eye-catchy, but another figure which is coming up now, that by 2030, India government will implement at least 300 gigawatt of renewable energy to the existing network. So in that sense, what I am trying to say, when we are just aiming such huge amount of penetration of renewable sources to the existing network, so our existing technology may not work. So therefore, we have to have some new technology, advanced technology. So that advanced technology is nothing the smart grid technology, right? So this is very simple layman word, just I'm replacing in front of you. So another motivation is, in 2012 July 31st night and day and night. So the Indian government has, big loss for us, right? So that disturbance was called as a blackout. And whole we have 5 grids, national grids. We have Eastern grid, we have Southern grid, we have Western grid, Northern grid, and Northeast grid. So due to one line, that line was basically, there is a report, all of you can read about it. There is a great, there is investigation about it, why it had happened, what was the main cause of it, this major disturbance, and how to mitigate these disturbances, right? So India government has put his, mostly the POSOCO, the Power Grid Corporation of India, is responsible because the transmission lines are owned by the Power Grid Corporation of India. So and that disturbance has been propagated from a 400 kV line, and that was connecting from Bina to Gwalior, and it was overloaded. That time the northern grid was drawing more power from the western grid. So therefore, that line was overloaded, and that overloading concept is known as load encroachment problem. And that load encroachment problem has maloperated one of the Zone 3 distance relay. So you see, a small distance relay protection. See, so whatever, you may design a very good infrastructure, right? So, but if your protection system is not that much of strong, then a small disturbance can collapse your system. It may take billions amount of dollar of money, rupees, right? So and not only that, it can also take life. If you suppose you don't have any backup supply for your critical loads, like flights, you have hospitals, you have emergency loads. So I mean, big industries. So in that case, if you don't have any backup supply during such blackout period, then what will happen? So those are going to be lost, right? So therefore, a single distance relay zone 3 mal operation has laid 2 days shutout. I mean, 2 days blackout in whole India, northern side and northeast side. So this was a major motivation again for all of us to rethink about it, how these major disturbances can be, avoided, and so that systems should not. I mean, see, even I'll tell you, these disturbances are not actual. They will not come to the network with an invitation or with a notice. I'm just going to be incepted on this date this time. No, and these are very inevitable. If your system is very strong, reliable, then these disturbances can be reduced. So these are some of the thought process and motivational points from my side. I'm just putting small points. There are so many other things, but in layman system, maybe in fact many other engineers have joined this course. So therefore, I'm trying to make it very initial points, very common and in general. So therefore, see, if you see from all around in the existing network, lot many pressures on the existing grid, right? So therefore, we need some flexibility, and that flexibility is only and only possible using the smart grid concept. So why this flexibility? What is the pressure? See, this smart grid. Suppose before 10 years I was using a simple Nokia set, but now I'm using a like in the smartphone like this. So what is? See, what is the need of this smart grid? This is smartphone, because today's date, you see, you are sitting over there. I'm sitting in IIT Roorkee campus, and you're sitting at your different places, and we are delivering our lectures. So this is the smartness. Even then, see, somebody says like internet is not good, laptop is not good, mobile is not good. Not at all. So if you can use for the betterment of the society and mankind, so obviously everything is good, right? So it is a requirement. It is not a desire. It is not a fancy item now. So therefore, the smart grid concept is not at all a desire. It is mandatory concept now, because we have a pressure on the present grid. If some pressure is there, so you cannot run the system anymore. The system may collapse at any time, and there may be some, lot of problems may come, disturbance may come. Right. So and the same standard lifestyle may not be followed by all the citizens of the country. So keeping everything in mind, the researchers actually come forward with the concept of this. And so these pressures are like increasing grid size and complexity, demand growth, increasing energy trend, changing load flows, bulk power transmission, bottlenecks, overloads, variable in feed. So these are some of the concepts why the pressure is coming on the present grid. So therefore, we need some flexible grid, and that flexibility will come when we'll make our grid smart. So similarly in US also, they thought, the smart grid word itself is originated from US. In 2003, there was a blackout, and they came to know that lot many losses are there. The Barack Obama was there, the president, and they thought of this concept smart grid from there. And there is lot many security acts came in 2007, and slowly they did so many things to change their network concept. And still, it is in the process. The increased uses of digital controls, dynamic optimization, integrate more renewable sources in a positive manner, in a very optimized manner, demand response, smart metering, smart appliances, storage peak savings, customer control, communication standards. So many things they have introduced one by one, so that the system will be more smarter. And based on this, if you see what is the smart grid concept, lastly, I just put in front of you that this is a combination of three things. The first one is the information technology, second one is the computer infrastructure, and third one is the communication infrastructure. So we should have a very good, very precisely, very dedicated information technology for our smart grid infrastructure, and a very dedicated communication infrastructure. Again, we should have a very good automated sensors, intelligent sensors, not only sensor, intelligent sensors. And of course, there should be automated controller. So, and these are basically the major key components of the smart grid. You have information technology, you have communication technology, you have automated control strategy, you have automated intelligent sensors, and then of course those packages, those are basically the one side, let us say the bride, I mean the marriage, the groom. So similarly, this major components when marry with the existing grid, and that grid becomes the smart grid. So this is how the smart grid, I mean, definition goes. And many federal, like global smart grid federation is there, you know. So this global federation is there is a global smart grid federation for all the countries. They decide what could be the standards for the smart grid, microgrid protection, stability, its monitoring. So they are basically globally some concept will come and every country has to obey those rules and regulations. So this is how this, if you just combine your existing information technology, communication technology, smart controllers, smart intelligent sensors with the existing grid, then your system will be more efficient, sustainable, economic, and secure to supply the electricity to the customers. So these four words, to achieve these four words, efficient, sustainable, economic, and secure. So previously the grid was there. You may ask the question that do you think that the previous grid was not secure? It was not economic, it was not efficient. Yes, it was, but it was not sustainable. Because why the sustainable word is important? Because now the carbon dioxide based coal belt generations are going out of stock, like, you know, so it has to be stopped. So the alternate way is to integrate renewables, right? So therefore the sustainability, reliability, secure, economic, those are every time it was there, but sustainability is a question. And of course, one more terms it comes here now, how it is accurate, how it is fast, how it is nature, how it is accommodating in nature, how it is self-filling in nature. So every aspect will come here in the smart grid era. So that was not possible at all in your general grid. So therefore it is very intelligent, green, efficient, accommodating, motivating, opportunistic, and quality resilience. So many, suppose there is some disturbance in the grid has to take care by itself. The operator is only there to switch on off the buttons. But the intelligent controller which are embedded inside the smart grid concept, that will take care, and it will just intelligently, it will just take decision. And within a fraction of second, it will take the judgment to save or to do what. So that decision has to be taken on the centrally. So these are some of the characteristics: more reliable, self-filling, self-monitoring, more secure, cleaner, greener, support widespread distribution generation, help customers achieve higher, thought output, and thus lowering the prices. See, the most important concept is this is a self-filling and self-monitoring system we are doing. And we are making our network, our environment more greener because we are just trying to penetrate more and more renewable sources, right? And help customers better control of energy. Let me share with you, all of you, one concept here. In US, earlier, even in India also, now suppose in some rural cities, if suppose there is a shutdown of power due to some problem, the fault or the disturbance, let us say one transformer is burnt, one line or tower is gone. One line is cut down and it is burnt. So in that case, the total area of that particular rural city, it will just they will see the shutdown, like, the power cut for not a day or two, not an hour or minute. They will see for month. I have seen. Even then today also the same thing is happening. So in that case, what will happen? Not many. Even then our per capita income is very low, and our per capita power consumption is very low in comparison to other developed countries. But still, we should come below the requirement, isn't it? So that case, the customers are helpless. They cannot do anything because the presence of the generating unit is centralized and it is far away from the customer's end. Even then they'll go for complaining, and then the replacement is too, it takes time, and our repairing, our maintenance is very poor, and reach to the customer's requirement is very poor. Even then we are trying for, and that's why this is a concept of this smart grid era or microgrid concept is coming up with a small area. If I can have some solar park, solar energy, quickly I can reach to the customers and I can supply some bunch of customers, and I can take care of those customers easily. So then in that case, what will happen? The customers can have the access to the generating units or utilities, and the utilities has a very good communication or care towards the customers. So the bond between the customers and utilities will be very strong, and the interruption in power will be less. So this is how the concept in US they built. Like suppose you have a card in your, I mean, suppose I'm just putting one card, I'm charging my card of my TV, my mobile, of my AC. Sometimes in some hotels and big restaurants, you'll see that you have charged the AC if you want to use it, and what type amount of money you have charged. So that period only the AC will run. Otherwise it will not run continuously. You cannot run the AC. Suppose for some dollar you want to charge it. So similarly, so if some customers, let us say, I'll just run. Now I see so many utilities are present from morning 6 o'clock to 10 o'clock. So let us say from 2 hours I'll buy the power from this utility, and for next 2 hours I'll purchase the power from this utility. Because the power is low, utility 1 from morning 6 to 8 and 8 to 10, the power is low at utility 2. So therefore, there is a option for the customers to choose the corresponding utility, and according to their price, low price, or maybe the reliability of the power, good quality supply of power. So this is a completely, like, it's a very good market. Electricity market is now coming to be like a very small market, and very user friendly and customer friendly. And it is the control is in both the hands. The utility has the power to control the customers. The customers also has the power to control the utilities. So this two-way communication was not possible earlier. So this kind of, I can even now the smart meters are installed in all over the India, and even in US lot many. So the smart meters, no need to go to your premises to meter the to read out the energy, how much you have consumed. Simply from your smart meter, what I have installed in your premises, I'll just record, and I can, with the Wi-Fi connection, before 1 kilometer, 2 kilometers, I'll just sense your reading and I can take it out. And even suppose you are not deposited the bills, then suddenly I'll cut. Some message will go to your mobile and your power will be off. So these are the some of glimpse just I put in front of you, the characteristics of the smart grid. When something burns, some situation, that means something you have generating, it has some characteristics, how it looks like, what is its behavior. So this is the glimpse, something I said in front of you, smart grid. Lot many things are there, lot many characteristics. So the question comes now, even then this smart grid is a very good concept. It's a very good vision. It's a different for some vision for the, I said from the beginning that it's a vision. It's not a product. It's not a service. Somebody will tell that, okay, it's a packing service, so you give us, so we'll use it. No, we all have to evolve with certain vision that how the things will be better for us to survive our network and survive our system. So this is like, the elephant, some blind people, they saw like the leg looks like a pillar, the body looks like a wall, something like that. The tail looks like a rope. So depending on smart grid vision, based on the utilities perspective, it is something different. The utility wants what should be my smart grid concept. Similarly, the customer also wants from its own perspective, what should be my smart grid concept or vision. Like for utility perspective, it should be high operational efficiency, and I can, multiple sources should increase in my utility concept. Reconfigured networks, increased resilience, self-healing of the networks, automatic fault location, first maintenance, demand management, long-term services. Similarly, for the customer side, I should get, first of all, an improved power quality supply, isn't it? And off-peak operation reduction energy bills. Suppose if I'm just not taking the energy during the peak hour, then I should get also reduced bill, because I'm just helping you to manage the peak, right? So, and there are so many concepts like customers, let us say, when some special loads are running, so the customers will be noticed that you have to stop your this loads, or maybe directly that can be switched off from the central control centers. So that means the sacrifice from the customer end also should be awarded, right? That's what is off-peak operation reduction in energy bills. And bidirectional interaction increase in choices. Like as I said with all of you, like in US, the customers are free to choose to buy their, purchase their power from any agencies. Because now it is deregulated market and anybody can enter into the market and they can share their energy. The small party can come, big party can come, so they can sell or they can, segregators are there. So that is the architecture concept. I cannot go right now. These are the just some glimpse I'm just putting in front of you. So this grid connected local renewable generation earning revenue. Suppose I have some solar rooftop mounted energy system, so I can just supply my, I can fulfill my demand, and also I can supply to nearby 2-3 buildings my supply. If it should be allowed to the customers. So customers have many perspective which are completely different than the customers. The utilities perspective. So therefore, I'm saying this is a reason. This is the depending on the type of utilization, the smart grid concept is different. You cannot say that it's a fixed country, it's a fixed quantity, it's a fixed device, it's a fixed service, so you just take it and utilize. It is not like that. It is varying in nature, very dynamic, and then only it will be adaptive in nature, right? So this is how I just first part I just explained with all of you that what is the smart grid concept. See, if you do not know what is smart grid, if I could have come to this microgrid, you may not get it properly. And maybe I don't know, ma'am. He was saying that some professor faculties and they experts they explain what is smart grid. But and this is my perception. This is my concept. What is smart grid in a very simple manner? The customer and utilities should work hand to hand. Nobody is here servant, and nobody is here, the master. So all together, all are master. So the utility has the same role. The same way also the customer has the same role. So together they have to come together and make the system more stronger and reliable. So coming to our microgrid protection, as I said, the monitoring part I may not cover because due to the time constraints. I can definitely share some thought process on microgrid and its protection issues. And the protection itself is a very huge field. And again, there are so many domains, aspects of this protection. So I'll pick up one concept and I can share with you. So this microgrid, you may come that why this suddenly from smart grid to microgrid? Because the microgrid is the cornerstone of the smart grid. If you think about before 10, 20 years, 30 years, and there was a NTPC, National Thermal Power Plants in Odisha, in our state also, like it is in Talcher NTPC, and so many other places also NTPC located. So this NTPC was a central control generating stations, and from there, after 1,000 kilometers, 400 kilometers, 600 kilometers, the power is coming from that central generation to the customers. So in between any disturbance will occur, so that area will be under load shedding and power outage for months and months. So that we don't need. We have to make small microgrids, small power poles, small power areas, like let us say one village, 2 villages, they will have some small solar park with some, of course, completely we cannot be dependent, present situation, we cannot be dependent on the renewables 100%. We have to go by step. And anyway, India government is planning for 100% integration of renewables, but it is not quite possible at the present scenario. Let me tell you the practical aspect. 20 to 30% renewable integration is possible, because it is not that we don't have renewables. It is not like that, because our existing technology cannot handle 100% renewable integration. Therefore, our present architecture, our present, the physical infrastructure of the power network is not in such a mood, not in condition to allow 100% renewable integration. So therefore, we are just practically, it is we are integrating 20-30% to the existing grid, right? And in some cases also, you will be happy to know that in some rural villages, we have urban microgrids, we have semi-urban microgrids, we have rural microgrids. So that means in different areas, different localities, we are planning different types of microgrids. Like I have visited, I have seen, not physically, I have seen that in South Africa, they have, I'll talk about it, different types of microgrids, nanogrids, mini grids. So this microgrids, as actually there's some villages, they supply some solar energy in the daytime, and in the storage devices, batteries are there, and it will supply to the in the night time. But of course, it is a very rural area, and they are not, you don't have very huge industrial loads, and maybe few agricultural loads, right? And some of maybe some schools and some few hospitals, like that. Not very huge loads they have. So they're just managing somehow the energy in their rural cities. Very poor. I mean, the people, they cannot pay very huge amount of money to the cost. I mean, the utilities. And that project was basically done by some California university, some faculty, some students. They demonstrated. There was a pilot microgrid, rural microgrid, rural electrification. That is a rural microgrid system. So it is quite possible. I mean, if you are aiming for a very smart and microgrid area, so it is not impossible. Okay, so that is quite possible in India, also in Bihar and in UP, Uttarakhand, in Odisha. So we and the government is having some rural electrification, rural microgrids. So these are very upcoming concepts, and I'm sure that very quickly we will be successful in this domain. And today we are discussing, maybe tomorrow we'll be having this kind of concept everywhere in the country. So this definition of microgrid, as I said, from the smart grid, I suddenly came to microgrid because the microgrid is just like you're building a building. So you're just making a building. So the bricks are the main cornerstone for the building. Similarly, the microgrid is the cornerstone. The microgrid will help us to move ahead to make the system smarter. And this microgrid is a combination of integrated energy, distributed energy resources. Distributed energy resources means DERs, that is your renewable sources like solar, wind, and storage system. So without storage, you cannot say system is microgrid. You have solar, you have wind, but the storage is not there, then you cannot say it microgrid. So the distributed, somebody says, some IEEE standard says distributed energy resources means, this one I have underlined, that is it consists of solar, wind, renewables, as well as the storage system. So which is basically, which is an integrated system, can operate in parallel with the grid or in an intentional islanded mode. So you can see this picture that the grid is present, and this side you have all the renewables, and you have active loads and all residential loads, industry, and you have customers. So then what I'm trying to say, that microgrid, it is connected to the grid, conventional supply, as well as it can also operate independently. Independently means with some disturbance on the grid side. So if I disconnect the grid supply, still it can survive. That is known as intentional islanding mode. So I'll talk about more this. This is one of the protection concept. So it can operate in a islanded mode, or it can operate with the grid connected mode. So these two options are available in the microgrid. So this microgrid is a small locality area, small, I mean, it has a power handling capacity up to 50 megawatt, and voltage level, somebody will ask you what is the voltage level, it can go up to 33 kV, and the power, it can go up to 50 megawatt. So small power handling capacity. So another concept of microgrids, the micro word means 10 to the power minus 6. So when you call a big, I mean, national grid, so suddenly to your mind, it will come that what is the power handling capacity of the grid? It is in the range of gigawatt, isn't it? Gigawatt. So in that case, what will happen? The micro, if you multiply 10 to the minus 6, what will happen? Then it will come down to what? Kilowatt or megawatt. So therefore, the power handling capacity is less in a microgrid. It is small microgrids. If you combine together, it will be a big grid, and that will call as smart grid. So this microgrid is not necessarily it is smart. If you want to make it smart, microgrid, then we have to introduce the intelligent controls, intelligent sensors, communication, infrastructure, then of course, so many other things which are actual the features required for the smart microgrid system. So this is our definition of microgrid: an integrated energy system consisting of interconnected loads, distributed energy resources, which are an integrated system can operate in parallel with the grid or in an intentional alignment mode. And one more point I just want to add: microgrid also can operate in standalone mode. What is the standalone mode? The standalone mode means there is no presence of grid at all. Only the microgrid is present. Okay, so only the microgrid is present and it is operating alone with the help of the solar, with the help of the storage. There is no question of there is no presence of main grid. Okay, so these are the major components, as I said, of the microgrids: energy supply system, energy storage capacity, demand response efficiency measures, energy management systems, utility grid interconnection. So this is how the mini grids after the this thing you have the mini grid. What is the concept of mini grid? After microgrid, there is a word. What is the mini grid? The mini grid already I have explained to you in South Africa. See this picture, it's a very good picture. You have a solar photovoltaic here and you have multifunctional inverter devices. And this is the energy storage and transformer. And here, after this multifunctional inverter devices, it will go to the residences and some agricultural processing. There is no big industries, right? So the big industries are basically absent here. So that is how I can just share with all of you what is this mini grid. And just a minute, I'm just going. Sorry for the interruption. So, so this is how this mini grid comes to picture. The mini grid, the microgrid is in the range of 50 megawatt, and the mini grid is the range of 15 megawatt. Now, so this United Nations Framework Convention on Climate Change, it defines that mini grid. Why the mini grid concept comes? Because if some rural cities are there where there is no reach of the main grid, so there we can just simply, those areas we can supply using some solar energy or wind energy or some other way of alternate renewable energy sources with, of course, some battery system. Without storage, the mini grid has no meaning because storage is the major requirement. And therefore, this storage, let me tell you, even today also, I mean, yesterday I saw one call from DST that the storage design and, strong, life cycle storage capacity. The storage is now a very big research area in country, not in country India. We have Indo-US, Indo-UK, Indo-Europe, Indo-Canada, many countries we are just tying up and they just want what is the concept, how to store longer duration for mitigating our requirement. So mini grid has no concept of presence of main grid. It has only the renewables and storage, and it is supplying some residences and agriculture. And it can go up to 11 kV level voltage, not more than that. Now, the third concept, which is very interesting, what is nanogrid then? We learned what is smart grid, what is microgrid, then what is mini grid. Now it is nanogrid. So this nano word, it's 10 to the power -9. So it comes further reduction of the power, right? So micro means very small, 50 megawatt. Mini means 15 megawatt. Further, nanogrid is in the range of kilowatt, 50 kilowatt, less than 50 kilowatt size. That grid can handle the power less than 50 kilowatt, and voltage is at the 230 volt level. So that means indirectly what I'm trying to say, a single building, just I wrote here, you can read here. The residential small commercial sites are called as nanogrids. Okay, it's quite interesting. So this concept, in fact, you will be astonished. In India, in many corners, we have nanogrids. I have seen personally in many customers, they have installed a small rooftop, solar panel to just run a charge or to run 2 tubes, 2 fans, or maybe some mobile charging concept, something like that. In some commercialized, buildings also I have seen. And of course, in IIT Roorkee also you can see, fortunately, our demand is more or less 6 to 7 megawatt. And we have in IIT Roorkee campus 1.6, 1.8 megawatt solar rooftop mounted renewable sources we have. And more or less we are going to, in near future, 2 megawatt of rooftop installed solar we are going to, mount very quickly. So this Tata Power has installed this rooftop solar mounted systems, but it is not optimized. If we'll optimize, then we may harness more and more power. So that optimization process, efficient process, is only possible by the system called as smart grid. So this is how this nanogrid is, and this nano means one building has its own capacity to utilize the power from the solar. And of course, if you see the teaching institutionals, at night time we may not need some, except the research scholars labs, research scholars wing, research labs. So we don't need any power supply in the classrooms or office rooms. So therefore, battery will be sufficient for supplying those requirements, maybe. So that is again in a research way out, but still some cases it is implemented, but it's not optimized. So this is how this picture will help you to understand what is smart grid. This is sky one is a nanogrid, small buildings. If combined together, it comes to be microgrid, and the blue one is combined together, you'll get the main grid, smart grid. So together, so I just said that the building concept of small area supply, so that what will happen, our energy handling capacity will be much smoother, and the power losses will be reduced, and interrupts in power supply to the customers will be also reduced. Why? Because we are taking earlier, before 20 years, we used to take power from central located generating stations, and it has to, the power has to travel like 1,000 kilometers, like 400 kilometers, 500 kilometers. Still today also we are not that much of dependent, but we are hoping, it is not imagination, it is tracking and putting a track. This should be our vision, and this should be tracked, this should be our way out to reach at that point. So this traveling 1,000 kilometers, the losses will be very huge. So 10 to 20% losses will be on the transmission itself. So we can reduce that losses first. And as I said, the customers can reach quickly to the, to your, utility very quickly, and to access and to sort out some problems. So, and at the same time, we are independent, right? Because we are not going to depend on any more existing sources like, fossil fuels, coal belt. And also we are free of all the gases, and our environment will be also clean. So these are some thoughts. You can also read more and more on this concept. So this is a kind of discussion and which you can carry out further. So this this concept of nanogrids, it's a kind of small home you can take. How it works, very simple. Some small projects also the students execute. We have renewable sources and storage. This microgrid controller is there, central controller. You have loads, and there's a gateway. So this controller will control the power supply from the solar storage, and the loads also it will control. See the connections everywhere from the central controller. And through the gateway, it will go to the external power utility. So from there, I can exchange my information, maybe power information, maybe all the data information, whatever, everything, all information, power information, data information to the outside world, outside feed. So this is how this nanogrid concept works. Like your grid, you have a smart meter, connect or disconnect. You have here, see, solar PV system. And this PV system is connected to PV inverter. And this inverter, you see, this is actually supplying energy AC, DC to AC, because solar generation is DC. The inverter will convert AC to DC, and it will come to the AC bus. And there's a energy storage which will just store your energy when it is it's not supplying the power to the grid. So that therefore this arrow mark is double-sided. and it can supply the power when it is required, and it can also take the power to charging and discharging. Therefore, this name is bidirectional converter. And from the AC load, we can, to the converter, we can supply to the AC loads, whatever we have. Maybe we have some critical loads, we have some, I mean, mostly in the homes, talking about it's a small building type nanogrid. And again, these red lines are basically the nanogrid controller, which will control every aspect. And mostly this red dotted lines has gone to the mostly the converter sections. Why? Because the converters we have active switches. The active switches means your IGBTs, or maybe you have diodes. It may be we may have MOSFETs. So those electronic switches has the pulses to switch on and off it. So if I can control those pulses, gate pulses, then of course I can control my operation. So these are the concepts I'm putting in front of you. So these are in research again. This is a microgrid made up of multiple grids. Let us say this is one building, second building, third building, fourth building, and finally I have one microgrid. And then this microgrid is connected to the grid. It is quite interesting. So these are the research. If you'll just model in a MATLAB or coding platform or some simulation platform, even in hardware platform, even in real field also, they are quite interesting. So again, these are thirst areas. So we have also AC grids, nanogrids. We have DC nanogrids, AC grids, nanogrids, 230 volt, as I said, 120 volt AC, 50 hertz or 60 hertz. And efficiency, these are 20%, 25% of AC grids. And in DC grids, we have 12 volt range, 24 volt, 48 volt. And efficiency is always better than your AC grids, because here the conversion stages are less. It is in the range of 95% sometimes. If it is AC-DC converters, then it is more than, 80% also efficiency. So these are some of the segments of the microgrid, and India is better in the military microgrid system. You know, this is a military microgrid area, 35% growth, community, commercial, remote off-grid, campus, institutional. So there are so many types of microgrids. These are the types of microgrids. So we can aim the microgrid concept anywhere we like, You know, off-grid means, suppose there is some some areas which are actually far away from the grids. Those are off-grid. We call it off-grid. Those are called as remote microgrids. Similarly, the military has also a great concept. Commercial, industrial, so many things are going on in worldwide. Okay. So coming to the so now you got some brief idea what is smart grid, why smart grid technology required, and what is microgrid, types of what is mini grid, what is nanogrid, what is the types of microgrids. So those some ideas you got. So what is now the coming to the protection aspect? See, when we are taking some advantage, of course the disadvantages are there, right? So when we're penetrating those renewables of storage for our benefit to the existing grid, we're making different kind of architecture or some designs. So they, of course, they have some their own limitations, and that is not limitation. That is actually the issues we have to overcome. So therefore, in microgrid or nanogrid or mini grid, whatever you can say, overall I can say smart grid. So there are a lot many issues as far as I can share with all of you. Maybe some of you are doing some research related to these areas, or maybe indirectly, directly linked to these areas. The foremost area of this smart grid, microgrid area or smart grid area is research, the power analysis, the power flow, AC/DC power flow. And second one is your, the stability of microgrid smart grid. And third one is the monitoring and control. Okay. And fourth one is the protection of those devices which are present inside the smart grid and microgrid. And next one is like you have how to develop a very strong and adaptive intelligent control system for the converter of the microgrid system, because the converter is the main heart of all the renewable sources, of the solar, of the wind, of the battery, whatever you can say. So everywhere we need converters. There, the control strategy of the converter should be very, very robust. And last one, last, this see that I'm just talking about the electrical point of view. There are so many other areas linked with this, smart grid, microgrid research. So how to design a very good topology for the converter of the renewable sources and batteries, isn't it? The battery has also converters. The solar system has also DC converter inverters. Your wind system has also converters. And how to design a very good converter so that my losses will be less, cost will be less, it will be cheaper, it will consume less power. So many things are there. And of course, finally, the smart grid or microgrid is not a one man show. Every time to every day I say this sentence. It is a combination of many engineering streams. While you design the battery, the chemical engineers has to play a great role. Mechanical engineer, they have to play a great role. Electrical engineer has to play a great role. Electronics, control, everybody. And communication engineers, then the computer engineers, so civil engineers. So everybody has a role in building this smart grid concept. Okay. So in fact, in our IIT Roorkee, we're running smart grid projects in many departments are involved, like architecture, civil, electronics, electrical, physics, so everybody. So very important, prominent. There are, so as I said, as I'll discuss today with you, some claim some portion of this protection is called as the islanding detection. So islanding is one of the prominent. See, when you are just designing some smart grid or microgrid, we are integrating the renewables. So this disturbances are very, very prominent. I'm not talking about the faults now. The faults are something other point. So I'll just talk about one concept of like islanding detection. So this islanding detection is one of the protection issue. And in fact, why I'm just worried for this islanding detection, because now every company, every utilities or customers, the government, they are just giving a notice to all the industry that your inverter should have an anti-islanding feature. Smart inverter should have an anti-islanding picture with feature should be embedded inside it. Then only will allow or will purchase your device. So that means this islanding is what we'll understand quickly, and then I'll tell you some conventional techniques which are available and why and what kind of techniques we have developed, and those things I'll discuss. This islanding is nothing. From here I'll explain you. Let us say we have the main grid, and we have this portion is the microgrid. So now this is the switch which connects the microgrid to the main grid. Let us say there is some fault on the main grid side, and the main grid has to disconnected from the microgrid. What will happen? If this is my, PCC, I think all of you know it. This is the PCC stands for point of common coupling. This one. This PCC is nothing, the point of common coupling. So where the microgrid touches the main grid, that connection point is known as PCC, right? So this microgrid is basically, as I said from the definition from the beginning, in the middle we discussed microgrid. We have, distributed generations, like this is your solar and this is your second distributed generation, wind. You have here the battery. Okay. Yes, of course, I also forgot your title of this course is power quality, mitigation. So this power quality analysis of the microgrid is also one more important area of research. I forgot to mention over there. So this batteries, storage, you have the renewables, you have the loads like non-linear loads, linear loads, unbalanced loads, balanced loads, three-phase loads, single-phase loads, whatever. So this microgrid system is now disconnected from the main grid, isn't it? Now, what will happen? Can anybody say from your side? The question is now for 1 minute, I just want to take questions from your side. If this microgrid is running in parallel with the main, suddenly there is a fault or disturbance in the main grid and the main grid is now disconnected. So what will happen to the microgrid? Can anybody switch on your mic and tell me? Yes.
issues, madam?
Can anybody help me? Because see, anyway, I'll continue half an hour more talking also, but I'm talking for last 1 hour, so I just want to listen for 1 minute, not more, because half an hour I'll dedicate for this concept. I explaining this concept. Yes, yes, go ahead. Be louder. Yes, please go ahead.
Actually speaking, load should, I mean, microgrid should run on its own. But inverter requires a reference signal from the grid. So as soon as my grid is disconnected, inverter will go into the off condition. So it will entire microgrid will fail actually.
How the inverter will go off condition? How?
It requires a reference signal from the grid to
Yeah.
convert that
So
DC into AC.
automatically it may not go, because it will, you're absolutely right. Many thanks to you. You participated in this question. That yes, it needs the grid frequency or voltage as a reference, right? The controller of the inverter it needs. But the point is, now the grid, when it is off, the inverter will not stop its operation, because it will take some different frequency as it has previously stored. So it will operate, but it will violate the voltage and frequency at the grid level. That is one point. Anybody wants to share any thought process? You are correct. You are correct. But the inverter will not shut down quickly. It will continue to supply for a certain moment. So anybody wants to answer this question? Any point? Any thought process you have? Let me tell you, so when this grid is disconnected, so there are two types, so you can write it down also. There are two types of islanding. One is unintentional islanding, other one is the intentional islanding. So this unintentional islanding, what I am talking right now, if the grid is, there is some disturbance, the grid is disconnected, then the rest of the microgrid is basically running with its own. So this is known as unintentional islanding. Unintentional means knowingly the breaker is not open. With our own desire, it is not open. Due to some disturbance, it is open, but it is not required. It is not desired by the microgrid system or loads. So therefore, it is unintentional islanding. And second one is intentional islanding. Suppose again the grid, anyway, the islanding means the grid is off. So suppose my grid is off and some areas of, see, this is a small area I have shown you. Let us say I have some 100 bus microgrid system or 200 bus microgrid system. So what I'll do, I'll just divide into different islandeds, small islands, like area 1, area 2, area 3, area 4, and I'll just try to them to just break into different areas where the power and generation and load will match, and they will just run in a stable manner. So in that case, intentionally I am just separating those microgrid areas in different small areas and small islands, and those are operating properly without affecting any, voltage and frequency violation, without having some voltage and frequency violation. So that is known as intentionally islanded areas. So coming again back to our unintentional islanding part, which I have started from the beginning. If suppose the grid is off, and if you all of you remember, I said in today's date our penetration of renewables is up to 20 to 30%. It should be noted down. If suppose I have 100% load, I am getting 20 to 30% from the renewables. So 70% I am getting from the grid. That means I am getting 70% power from the rest grid. So when the grid is off, suddenly 70% power is off, and I am only getting 20-30% power from the renewables. However, my load requirement is 100%. So in that case, I have to shut down some loads, or I have to shut down the DGs. Any one I have to do, because I have, suppose for example, in this microgrid, my the required load is 8 megawatt. I am getting the power from the renewables 2 megawatt. I am getting 6 megawatt from the main grid. My main grid is off, means 6 megawatt load is off. The 2 megawatt of load I have to keep, another 6 megawatt load I have to switch off. Or I have to do one thing, I have to suddenly switch off all the renewable sources. That's all. without keeping, without touching anything else. So this unintentional islanding creates voltage and frequency variation. Why? Because when the main grid is off, due to this power imbalance, the generation is less, load demand is more. So there is a mismatch between load and generation. Therefore, the delta P, delta Q will be basically the governing factor now. The delta P controls the voltage and delta Q governs the frequency. In distribution network, in the low voltage network, 230 volt cable level, the resistance is dominating in nature. So therefore, the P controls the V and the Q controls the voltage. But it happens in opposite in the, this concept is just opposite in the transmission. So this 20-30 megawatt, 20-30% of renewables may or may not supply to the loads. So in that case, we have to shut down, we have to de-energize the DGs. As one of the candidate he said, the controller of the renewables, wind and solar, or even the battery also, they receive the reference voltage and frequency from the grid. So in that case, it may go for unstable mode of operation. And of course, my voltage frequency will just deviate from its own decided value. So therefore, what I'll do, I have to switch off the grid pulse of this inverters of my HVDC. So then what will happen? If the switching pulse is stopped, then the inverter will stop supplying to the grid. So that is a forcefully, I am just de-energizing the renewable sources. This is known as unintentional islanding. All these operations, once I have to detect that the grid is off, that process is known as islanding detection. So according to IEEE standard 1547 series, all of you can write 1547 standard, IEEE 1547 series, this process should be detected within 2 seconds. 1 to 2 seconds. In some cases also it is done within 0.3, 0.5 seconds. It varies from country to country. Like in Canada, Europe, they detect within 0.5 seconds. In US, India, we detect within 2 seconds. So in many other countries within 0.3 seconds. So it varies from country to country, depending on their network, their size, so their load criticality, everything. So that is what is, somebody may ask you, why in unbalanced, unintentional islanding, we are so much interested to shut down the DG? What is the need? Because suppose at this bus, you have some loads present on the grid side loads, and even there is some, suddenly the grid is off, but those customers, the queue person, they'll come to the grid is off, but still the load is getting power from the renewable side. So therefore, for safety point of view and power quality issues point of view, and some loads which are very sensitive, like induction motor, something where the frequency dependent, voltage dependent loads, they may also fail. They are breaking down of the rotor may also happen. So therefore, to maintain the system very healthy, to overcome the power quality issues, for safety point of view, for safety point of the loads, everything, we have to shut down or de-energize the grids. That is known as unintentional islanding. But for your information, the IEEE nowadays is not encouraging to the microgrid utilities, or this concept should be avoided. Why? We should go for intentional islanding, because at least some portion of my energy should be utilized by the load. Why should I switch off the renewables? Why should I suppose 20% generation is there in the microgrid, so that those 20% power can be supplied at least for 20% loads. Why should I switch off those renewable sources? So therefore, it is very essential to have intentional islanded systems. But now, still in India, that even in other countries, the intentional islanding scenario is very less, rare, you can say. So we have in the paper or research and industry, you can see we have more and more concept on unintentional islanding detection. Slowly, the researchers are also going towards intentional islanding scenario. So these are some of the conventional passive, today I'll restrict to only unintentional islanding detection. I'm not going to intentional islanding. So again, this unintentional islanding techniques are of different types. The first 4 types. The first one is passive, second one is active, and the third one is hybrid. Hybrid means combination of passive active, and then the fourth one is the communication based islanding detection technique. So I'll talk about passive, some conventional, and then I'll go for active. Okay. So this rate of change of frequency, phase jump detection, rate of change of power, rate of change of voltage. So those are basically very common conventional passive islanding detection techniques. And because, as I said, during the islanding, on intentional islanding cases, there is a mismatch between the generation and the load. So there is a mismatch between the P generation P load and Q generation Q load. So due to that mismatch, what happens? There is a change in voltage and frequency. That change, can you just take it, and can you just take the rate of change of that change of voltage and frequency, and that when it will cross a certain certain range threshold, then it will detect the the islanding situation. So here the major drawback of this conventional passive islanding detection technique, the first one is here if the power imbalance, the power mismatch is less than 10%, these techniques fail. The power mismatch is less than 10%, then it fails. First. Second, these techniques are dependent on the threshold settings. That is the second demerit. Therefore, many research is going on in this direction, in these directions, how to overcome these issues. So what is this NDZ, non-detection zone, means? Let us say I said from the previous slide, if the power mismatch is below 10%, then the technique is not able to detect whether the grid is off or on. Okay, so therefore this system, if it is small squares I have shown here, green one, blue one, red one, the small green one is for less power mismatch, 2%, 3% band of power mismatch. Blue one is basically 10 to 15%. Let's further it increases. So that means if my this zone, I mean the NDZ increases, I mean the percentage of power mismatch increases, then the conventional technique fails. That decreases, swings, then it decreases. It fails. So for higher power mismatch, it is better. For lower power mismatch, it is not good. So therefore, the researchers, they go for active islanding detection techniques. In this regard, also we have proposed some techniques, but I have not kept here due to time constraint. But I'll explain you some research we did in active islanding detection areas. So I'll tell to you. Recently, we have published some papers. So what is this active islanding detection technique? The active means here you see this picture. We have some solar and we have some DC-DC converters. Some people who are working in this direction, like in the powertronic side, they can attack these problems easily because their work is to design the topology. It's not like that. The power group also they can do, control group also they can contribute here. So this DC-DC converter we have inverter, and this inverter is basically the active elements. Why? Because inside inverter we have IGBTs, we have MOSFETs, and we have diodes, we have active elements basically, not passive elements. Passive elements are like resistor, capacitor, inductor. So this, if I can control, I can manipulate in the controller of the inverter of the solar panel, then I can detect or not this islanding. It has been, a curiosity has been generated inside the researchers and it is working fine. But what we have proposed, initially the researchers, they just add some percentage of disturbance signal inside the controller of the inverter, and they see at this terminal of the DG or renewable source terminal, what is the change in voltage, what is change in current, what is change in frequency or impedance, and then accordingly they take the decision whether the grid is connected or disconnected. But they inject the disturbance for 24/7. But in our case, we do not inject the signal, disturbance signal. In that process, what will happen if we inject 24/7 the disturbance signal, then your power quality issue will come again. Because it is a small disturbance you're injecting, even then throughout, even then there is no islanding situation, still your voltage and frequency will be deviated a little bit. So to overcome that, what we did, when there is some disturbance, That time we will inject the disturbance signal. Other time we'll make it 0. That is our concept. And further you can see, this is a very huge work, 2 works I'm going to present in front of you. You can read the papers, it is available on my website. So this work is very interesting, that we are not injecting the power throughout, but we are just injecting the disturbance, only when there is some disturbance signal, which there is some disturbance in the network. Then only. Otherwise, no. The first work we did, there is a frequency disturbance triggered D-axis current injection scheme for islanding. In this case, what we do here, very easily I can explain here. This is actually solar, and this is my inverter, okay? And this is my DG terminal. DG means what? DG means the solar connected to an inverter and connected through a circuit breaker to the grid. And this is my grid side. So at the grid side, we have measuring the frequency with some device we call as FDR. The FDR stands for frequency disturbance record. Okay, this is a new device and its precision level is quite high, and it will measure the frequency of the grid. And this FDR will measure the frequency at the terminal of the DG. DG stands for distributed generator. Now we will take the difference of these two frequencies. This two frequency difference is very low in this paper. We have taken 0.005. If we could see this paper, very low. A small change in frequency also it will catch, and that precision, this FDR is so accurate. It measures the frequencies very precisely. So this frequency difference will go to the inverter controller, and if this is exceeding this threshold TH1, that means there is some disturbance has been happened in the network. This is very important point all of you should understand, that if this AFG minus AFDG is some difference is there, then only the injection of disturbance is going to happen. Otherwise, no. And during suppose the grid is not disconnected, so this FD and FDG will be how much? It will be 0. When the grid is disconnected, then there is some disturbance. There is some difference between FG and FDG. So that disturb signal, that different signal will help us. We'll just speak, yes, now you start injection of the disturbance. Okay. So then we'll inject like this. This is the controller of the inverter. So D-axis control side and it's a Q-axis control side. I'm not going in detail of this. Is a DQ controller of the inverter of the solar system. And then by injecting the disturbance ID star, then you will get some pattern of the pulse, PWM pulses, and it will go to the gate of the signal as a gate signal to the IGBTs of the inverter, and then corresponding voltage and frequency will be something different. So that V by I, VD by ID, this is VD by ID ratio we have taken, okay, at the terminal of the DC, and we decided this VDH, that is a D-axis impedance, and if it exceeds certain threshold, then we'll say yes, there is a islanding, otherwise no. So for detailed things, you have to go through the paper. I just say to you layman language what we did and why it is like this. What are the mathematics behind it? So you have to go through the paper only. These are some of the results. This is the left side is the islanding case. This is the non-islanding case. The non-islanding case, just share with all of you, means the grid is connected, but there is some fault, there is some line disconnection, there is some DG disconnection, some other capacitor switch on off. Okay, so load switch on off. So those are known as non-islanding situation. So remember, grid is off means islanding, and other disturbances are called as non-islanding. So during islanding, there is a very clear-cut trip signal is generating, and in the non-islanding, the trip signal is 0. This paper is accepted basically in a IEEE transaction industrial informatics. So one more technique based on same concept here. That is there actually we injected the current, but here we are injecting simply the difference is the reactive power. Okay, this is the only difference here. And there we used the FDR, but here we have used micro-PMU. Why micro-PMU? Micro-PMU is actually a monitoring device. My topic of this was monitoring, but due to this time constraint, I could not talk about monitoring. Maybe in future we can go for one more class. This micro-PMU is a very huge area coming up. Still I'm using the word coming up. it is not installed. This helps in monitoring as well as supplying the positive, negative, zero sequence components of the voltage and current to the anywhere you like. You can access from there. It's basically a monitoring device. So as we need the voltage, a positive sequence voltage current, so therefore FDR we have not used here. We have used here microgrid. And from there we inject the disturbance like this. In the previous controller we used the PQ controller. Here also PQ controller, but the Q injection here is a Q disturbance, and it will go to the Q reference signal of the controller of the voltage source converter, and then corresponding the pulse will be generated. So this is how this technique works, and again the results, some of the results I have kept here. Here the trip signal is generated when the delta F, I mean it increases the certain threshold, and this paper is accepted in IEEE transaction smart grid. So what I'm trying to say, by combining the two techniques, what we did is that I request all of you, somebody is really interested to work, you can refer to these papers and definitely will get all the basic or conceptual knowledge. What is this active element detection technique, and what is the technique we have developed, and what are the merits, demerits of the conventional technique, and what is the advantage of this technique. And here what we are trying to do, nothing new or nothing very big thing, but only the concept here is don't inject the disturbance for 24/7. Just you inject the disturbance when the disturbance is coming to the network. Otherwise, that is the main contribution of these two works. And yes, of course, we are using the concept of new devices, their measurements like FDR and Microgrid. So yes, I'll come to end of my session today. And before that, I just want to say there are so many concepts as the smart grid is protection of microgrid is concerned. One more area is we are working in our laboratory, the restoration of the smart grid system. Suppose you have islanded this network, how to restore back, reconnect back to the network. That is also very challenging. And one more area we're working like coordination of overcurrent relays. That also, the overcurrent relays are basically dedicated for the protection of the feeders of the distribution network. But during fault and all, presence of renewable sources, storage, their behavior is different. So we are also working in that area. Now there's some DC microgrids also we are working. And some of the students are working in the differential relaying concept, and some cyber security attacks. So many things where we have a good group of students in our IIT Roorkee electrical department. So whatever I discussed, those techniques also we have implemented in a hardware platform, HIL. We call it as hardware in loop test bed. We have a RTDS, we call it as real-time digital simulator. This device, it has 6 racks. This device is only in IIT Roorkee, IIT Kanpur, IIT Bhubaneswar, 1 rack, and POSOCO and CPRI. So very in few places, like 4 or 5 places in India. And fortunately, we got it in our laboratory. And here we have all the facility to generate the microgrid system, smart grid system, all the wind, solar, storage, everything we generate here. And the signals, analog signals, we take it out from the device. Suppose you are simulating in MATLAB or PSCAD, you cannot take signals directly to the output. That is way out, but that is not so easy. But here we have GTAO, Giga Transfer Analog Output Card, GTAI Analog Input Card. We can take the digital signal out, analog signal out, and this is our controller outside where our technique will run. And this will receive the analog voltage signal, it will process, again it will come back to the RTDS to open the circuit breaker or to de-energize the DGs, whatever you like you can do. This is known as HIL test bed. Okay. So we have also one more lab, DC microgrid lab. I'll call it as Dr. M.P. Varshney Smart Grid Laboratory. Dr. M.P. Varshney is one of our alumni. He has sanctioned this project money. I was the in charge of both the labs, and we developed something. And in future, we are trying to do more. In this lab, we have solar panel, wind panel. We have here you read one. This is fuel cell. We have batteries here. So there's a good district grid AC grid system. So there are so many other things also there I have not kept here. So this is in process actually. Let me tell you frankly, we are also planning more and more smart grid beds, showcase beds, and pilot projects in our. It is actually developing. Other faculties are also involved. My personally, I have a keen interest to develop more practical test beds. Let us see. I need all your blessings and all your encouragement to do good research in this field. And honestly speaking, see this research is not for our IEEE papers or IT. Rather, what kind of problems the industry is facing, and we can interface more and more with industry person for the globe and India, so that we can know what is the problem going on there, so that we can solve in our laboratory mode and we can give some solution in product form or in software form to them, so that it will be helpful for the mankind as a whole. So this is all from my side. Thank you so much. Any questions? We can move forward. Thank you so much. Thank you, ma'am. I'm done. So any questions I'll take. Hello? Hello, ma'am? Hello? Hello, ma'am? Hello, ma'am. Am I audible?
Audible,
Yeah.
ma'am.
So this is from my side. That's all. So any questions? I'll take your questions.
If we are considering
Hello,
Yes,
ma'am.
yes, please.
Hello.
Yes, please go ahead.
Morning, ma'am. I am Baladari Kannan, head of the department from Sri Vidya College of Engineering Technology, Virudhunagar, Tamil Nadu. Ma'am,
Yes.
suppose if every house having solar panel 500 watts,
Yes.
that
Yes.
may be mandatory. And
Yes.
industries, they must provide 1 kilowatts in every industries. So, PV panel gives only active power only.
Yes.
So we need reactive power. What type of reactive power compensation we have to need in its system, ma'am?
Yeah. So very good question. See, actually, I'll tell you two things here. If you have some both active reactive power loads, of course the system needs reactive power, no doubt. The point here is, if I can make some angle difference between the voltage and current which is generated by the inverter, you have to maintain you don't have to maintain the unit power factor of the inverter. Rather, you have to maintain some angle between the voltage and current generated by the inverter, so that it will produce both active and reactive power. The inverter itself will provide you the active and reactive power. You understand? I think the inverter itself has the capacity to deliver the reactive power to the grid also. It will maintain the angle between the voltage and current of the inverter properly. Instead of making this angle unit power factor means 0, you have to maintain some angle, and that angle is only possible by generating the pulse with the pulse in such a way that the angle difference will be maintained. So that is one way. And second way, if there's some local loads need, suppose you are supplying the active power from the the solar panel through the inverter, that is fine. Then it is supplying to the loads. And if the loads need some reactive power generation compensation, you just connect a source of capacitor bank near to the load in parallel with the loads, and that will fulfill your reactive power. These are the two ways out.
Okay, ma'am. Thank you, ma'am. Thank you.
Thank you. Any further questions? I'll be happy to answer your questions. And it's a great day for me.
Ma'am, there is a question, ma'am. Can I
Yeah,
read out?
please.
From Rohini, does power theft by hacking a major problem in smart grid?
That's good. That's a good question. So, real, and therefore, this smart grid is coming to picture to just catch those thieves, isn't it? So, my first point, there was also lot many, last 30-40 years the same discussion is going on in India. Mostly, suppose some stay. Let me tell you the practical aspects. Some villages, rural villages, they have some areas actually we design. While we design some power supply to some areas, we call it as planning mode of the network. Let us say this particular village is demand is like some 100 megawatt or something. Let us say, for example, I'm talking 50 megawatt, whatever, or 10 megawatt. But however, when we see the surplus, the power demand is crossing the limit, isn't it? I have seen in personally the transformer will burn, the line will burn. Why it is happening? Because due to the overdrawing of the power, which is for what it is not designed. So in that case, what we do, it is called as power theft. That is one point. And second point, sometimes see the people put hooks on the line. They put some other the bypass of the energy meters. So many things that they are doing. But therefore, there is a concept smart meter is coming up. So in smart meter, what will happen? You cannot scratch anything. You cannot touch the device. Even you will touch it, suddenly one message will come to the nearby operator that your device has been touched and scratched, or it is bypassed, or it is disconnected or connected. Quickly, the crew person will make the power off to your house itself, because the area they are making in such a way that the power supply to which house, which corner, so they have all the powers to switch off the power to your mode, your area, or your residence, whatever. So this is one point. And second point is, you may question that, so the power is coming from one line, one feeder, and in the feeder there are many customers or loads are there. Then how to do it? So that concept is now design mode, that we have to have very sophisticated substation, or you can call it as smart microgrid concept. Every individual house should have some controllable MCB. Remember this, controllable MCB. We cannot keep a simple switch or cutout over there. We have to keep controllable switch. Suppose somewhere some disturbance is coming, I'll just, being from my far away from the substation, the operator can control your controllable MCB. MCB will be down. So these are some of the steps are taking up, and moreover, we have I didn't tell you about the advanced metering infrastructure. So this advanced metering infrastructure AMI, you can read, you can type it. This is the main feature of the smart grid, and this is only for those tips which will be caught quickly. So these are some of the thought process I can share. Is it okay, ma'am? So Avinash Deshpande, you can.
Yes.
You can.
Which is the question from Avinash Deshpande, sir, ma'am. Which is the best simulation platform to carry out microgrid and nanogrid studies?
Yeah. So the simulation platform, see, there are many. See, the MATLAB is always king. I cannot say the MATLAB is the worst one, and others are. Even though we have Dislent and we have PSCAD, we have RSCAD. RSCAD is a software platform in RTDS, real-time digital simulator platform. So there we have RSCAD environment. Why this? I suggest the real-time platform, because whatever, see, somebody is simulating in MATLAB and somebody is simulating in RSCAD. The major difference is in MATLAB, you don't, those the modeling, whatever the codings they have done inside, it is not having it doesn't have the nonlinearity within it. But transients and nonlinearities are major components in power network. But in PSCAD, isn't it, EMTDC, it stands for electromagnetic transient with containing decaying DC. So in power system is full of transients, then decaying DC, then those on dynamics. So those non-linearities are basically taken care within the models which are available inside the PSCAD and RSCAD. So therefore, we more believe on RSCAD, PSCAD platform rather than MATLAB for our point of view. At least in MATLAB, you can go to control, you can take the control blocks. But somebody is taking a solar panel wind generating system from MATLAB, and somebody has taken from RSCAD, PSCAD. The RSCAD, PSCAD simulation will be more authentic, because they are the non-linearities or dynamics or transients are very mimic. It will mimic the real world concept. So therefore, it is, what do you mean by real time? Real time means it is the clock watch. In clock watch, in my watch it is 1 minute means 1 second means in the simulation also it should be 1 seconds. It is 1 hour means there also simulation should be 1 hour. But in MATLAB, this clock was and the simulation timing doesn't match. So therefore, this is the difference between offline and real time simulation platform. So these are my suggestions. If you do not have platform like PS card or RS card in your lab, MATLAB is always advisable. Is it okay, ma'am? Yes. Yes. So next question, ma'am.
Till now, there is no question, ma'am. Maybe
Yes, ma'am.
2 minutes to
Ma'am,
wait.
what type of battery is one somebody wrote Samil
Yes,
Samila
yes,
K.
ma'am. From Sharmila, ma'am, what type of battery is used in inverter?
Yes, very good question. See, there is different types of batteries. Now, recently, I think all of you heard that somebody got this Nobel Prize for lithium battery. So, lithium ion is now the best one. If time permits, you can mail me. I can send the types of batteries. The lead acid battery is the worst, and the lithium ion is now coming up is the best. But honestly speaking, no battery is best because anyway there is a waste out of it. But still, without batteries, we cannot survive then because if you not store it, then therefore there are so many storage flywheels. You have supercapacitors. You have the supercapacitor is the best one now coming up, but even then the lead acid the lithium ion battery is just beating everybody, beating to all the it beats to all the storage plants. And maybe we could have like pump storage power plants where you can during the storage time the water will be taken up, and when it is required it will be come down and the generator will generate the power to supply the energy. This kind of arrangements we are doing. So the battery is still in a, as I said to all of you that US, Canada, India, Europe, who are actually the leading front of this microgrid, smart grid, renewables. They're eager to have concept of battery. So research is always it's going on. Nothing is finalized. So lithium ion is the best one.
There's a next question, ma'am, from Rajkumar sir. The recent trends in inverter for microgrid or smart grid applications, ma'am?
Recent trends in yes. The recent trends in inverter for microgrid smart application basically the breeze. So see that still I'm not from my background is from power system, but still I work in this area, so therefore I have some few knowledge in smart topology of inverters also. The H bridge type, the inverters which are actually having the less loss and having very high frequency concept, and it should not inject more harmonics to the grid. So those kind of inverters we need. The first requirement of the inverter is it should not inject the harmonics, and second one is it should not have switching losses, and third one is it should be able to stabilize when the grid is off or grid is on. So these are some of the types of topology what we require for the smart grid environment of the inverters. And I request to you, all of you, you can follow the series IEEE 1547 series. This is a very promising standards followed by the whole. I mean, there is a group task force who are working towards these smart grid standards. AC grid microgrid standards, DC microgrid standards, inverter topology standards, communication topology standards. All the standards are actually they have formalized, and few are also in working condition. So you can download those IEEE standards 1547.1, 0.2, 0.3, 0.4, 0.5, 0.6. Everything is written over there. So please see those standards, and so many things you can come from. You will know from there. That I can advise all of you. The inverters should be, I can tell you there's so many operation of the inverter. One is the grid following mode. One is for grid following means when the grid is connected, and one more is grid that is disturbing. Means suppose the grid is disconnected, then also the inverter should be stable and it should operate properly. So those are basically the different types of topologies of inverters coming up with different control strategy. So when the inverter is compatible to withstand everything, So that is known as a good topology design or control design for the smart grid or microgrid.
Thank you, ma'am.
Yeah. So so many other aspects of there. Some protection aspect is also linked. So we have to robustly we have to design the inductor capacitor or diodes, so body diodes or the IGBTs in such a way. If there is some fault in front of the inverter, it should clamp the current level to 2 per unit, 5 per unit to save the components which are present inside the inverter. So those are also one of the important aspects of the inverter design. Yes, ma'am. So any from the participants? So
That's all, ma'am.
yeah. So yeah, I'm free to discuss till I have time in 15 minutes. So if anybody is really interested, I'll be thankful your questions. Otherwise, we can take off. So is it okay, ma'am?
Yes, ma'am. Participants, you can unmute your mic and you can ask the questions also.
I told that I'll share these PPTs to all of you, and my mail ID is in front of in my website, or I can write here to all of you. I'm just writing here my mail ID. Any queries, anything I can, if I can do, then I can help you, or any further related to any other areas, I can forward to my colleagues and my, we have a very big group in our IIT Roorkee where many faculties are involved, not me only. As I said, the smart grid is not a single man show, it's a multi-man show. So all of you should come forward together to work for, like, some group they're designing the topology of the inverters, converters. Some group they are designing, like for my side I'm designing the protection aspects, and some Professor NP party, some Dr. Bhavesh, they're going for demand side management. So I'll be very happy to solve your problems. If I can not, then I can forward to my colleagues, so they will also help you. And I welcome to all of you. After this COVID, you can visit our labs also, smart grid laboratories. And anytime you need some help in hardware platform, software platform, IIT Roorkee is there to help to all of you. Because those facilities are basically developed by the central funding systems, IIT funding systems. Even though we are the medium, but it has everybody has the right throughout the country to access those facilities. This is from my side. Thank you, ma'am. Okay, ma'am. Is it okay, ma'am? We'll stop here. Ma'am, your voice is not audible. Usha, ma'am, your voice is not audible. Yes, please. No, but still it is not audible. I think your mic has some problem. So,
Ma'am, Usha ma'am, not audible, ma'am.
yeah, madam is not audible. I think your mic has some problem. So let me tell to all of you that very soon we were going to arrange one workshop, 2 to 3 days workshop on smart grid. I'll send invitation to madam, and he can circulate to all of you, and you can come forward and you can join. Where we have some laboratory demonstration, software demonstration, we'll do all. So I'll help you, and maybe you'll help me. So I need all of your blessings and your encouragement to move ahead. That's all from my side.
Ma'am, you're
Usha,
still not audible, ma'am. Usha, ma'am.
ma'am, you are not audible. Ma'am, you are not audible. Can you check your mic, ma'am?
Feedback was filled, ma'am. Shall we leave the session, ma'am?
Hello. Now it's audible, ma'am.
Yes, ma'am, you are audible.
Thank you very
Yes,
much,
ma'am. You're audible, ma'am.
for your
Slightly improve the voice, ma'am. Increase the voice, ma'am.
ma'am. Hello.
Yes, madam, you are audible,
Hello.
please. Ma'am, you are audible.
Thank you very much, madam, for your valuable information session. The two basics, microgrid, nanogrid, smart grid explanations are very excellent, ma'am. Thank you very much for your informative session, ma'am.
Thank you, ma'am. Thank you so much for inviting me. I'm very thankful to all the participants who are present hearing. They heard me, and so I'm really thankful to all of you. I'll be very happy for joining when you'll again we'll do some joint programs. Even very soon we are going to organize some workshop in IIT Roorkee, so I'll give you some invitation to all of you. So please come forward and join.
Yes, ma'am.
We will be in
Thank you,
touch.
ma'am.
Madam, kindly send that workshop on smart grid details,
Yes,
please.
yes. Very soon we are planning it. So when it will be solidified and finalized, I can forward to ma'am, and then she will forward to all of you. So we
Okay,
need your
madam. Thank you.
cooperation.
Please,
Yeah,
madam.
Yes,
Please,
ma'am.
madam.
we need your
I'll
we need your
forward.
cooperation and your yeah. Please, ma'am. Yes, ma'am.
Thank you, ma'am. Thank you.
Thank you, ma'am. Thank you, ma'am. Thank you so much. Thank you all. All the best, and I wish you a very happy stay during this pandemic situation. Please take care. Bye.
Thank you, ma'am, for your speech. It's very useful and informative about microgrid system. We are able to enhance our knowledge in this thing. Thank you very much, ma'am. Participants,
Yes.
kindly join the afternoon session at 2
Madam,
o'clock.
I have one question, madam.
Yes, sir.
Yes, please.
Madam, where we will get the recording of this session, because this is a very nice session. So that we can listen it once again, madam. Is there any YouTube channel or somewhere you will share this recording of this video
Usha
of the
ma'am, can you
session?
just send this video to all of you, recording one?
No, ma'am. We are waiting for the completion of the sessions, ma'am. SVTP2. It will be ended by
Yeah.
24th, ma'am. Then we have to get permission.
Okay. Yes. It will depends on the Usha ma'am, so you can contact them. So please, you can help, and Okay, ma'am. So shall I leave now? Shall I leave now, ma'am?
Usha ma'am.
Okay, thank you, ma'am. So I'm leaving.
Thank you, ma'am.
Thank you
Thank
all.
you very much.
Thank you. Thank you for your kind cooperation.
Thank you.
From
Madam,
higher
can you
education, I'll give you, ma'am.
Madam, can you provide the recording of this session, of the FDP session of each session?
Sir, we'll communicate you after the end of this phase 2 session, sir.
Madam, every ICT sponsored STTP shared their link in the YouTube, everyone. Sir,
Yes, sir, we'll communicate, sir.
because this FTP is for learning purpose. So unless or until you share it, so we cannot listen the thing once again, because in a single 50-minute session, it is not possible to grasp all the concept. And every ICT STTP program shared this PPT, video, everything for the faculty members, because this is a faculty improvement program at least. So please
Actually,
kindly
sir,
share the recording of the session, madam.
yes, sir, it will be posted in YouTube channel, sir.
Sir, excuse me, now it's audible now, Karkurli.
Yes, ma'am, yes, ma'am.
Sir, Sumant, sir. Sir,
Yes,
we
yes,
have to
madam.
complete our STTP all sessions, sir. If the professors have shared their PPTs, we'll send it to you along with your participation certificate.
But
Till that,
madam,
you have to
YouTube.
kindly cooperate, sir.
Yes, madam, I am cooperating, but I am telling that in AICT STTP YouTube channel is there, and people can see once again this lecture, because this lecture are very, 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 very informative. So unless or until you share it YouTube, so
Yes,
we
sir.
cannot see it once again. We cannot develop ourselves. And the motto of this AICT STTP to develop the faculty.
Yes, sir. It is the improvement of your teaching learning process only. For that only, I have insisted in the introduction of our chief guest know about the STTP. It is the teaching learning process enhancement for our side, faculty side.
Yes,
We will try
yes,
our
madam.
best, sir.
I am telling you, please share the recording in YouTube so that we can see it once again. Several times
Okay,
we can
sir.
see it.
Okay, sir. Okay, sir. We'll see, sir. Dear participants, kindly assemble at 2 o'clock. Dr. Uma Madam G. Uma Ma'am, Anna University Professor will be handling a session. Kindly join 1:55. Uma இருக்கீங்களாமா?
Yes, ma'am, I'm there, ma'am.
நடுவுல disconnect ஆகும். Same time, same laptop I'm using. எப்படி disconnect ஆகுதுப்பா? Volume alone? Can't understand பா. எப்படின்னே தெரியல எனக்கு. Full volumeல இருக்கேன். நான் 100% வச்சிருந்தேன். Recording stop பண்ணுங்கப்பா.
Yes, ma'am. Okay.